Here's a cool looking circuit. This is a dev board for the RP2040, which is a microcontroller made by the Raspberry Pi Foundation. And here's the physical board. This isn't like that complicated a board. There's a few odd complicated features of it. What makes this special is this was assembled by a machine. This board was assembled to specification, to order. So when you're in the process of submitting your Gerbers, you also have the option of submitting a bit of extra data and have that manufacturer assemble your board for you. A lot of PCB houses now offer assembly, which is amazing. You could certainly solder this center microcontroller component by hand. If you used a solder stencil and a hot plate or a reflow oven, whatever, you could certainly do it. But man, it takes the edge off, especially if you start using really, really small components. Another advantage is that you can just reorder this. In my account now, I can just go through the history and hit purchase on this. And I know that this is going to appear exactly as it is in the mail in a couple of weeks. It's unlikely that you'll do this a lot for like prototyping stuff, but hey, this is a great tool to have in your back pocket, even just from like a professional development point of view. This video is all about PCB-A, or PCB assembly. PCB assembly is going to require a couple of things from you. The first is a bill of materials, and the second is a position file for all the components that need to be placed. The bill of materials has a lot of flexibility. You can be totally prescriptive in your schematic about the parts you want to use from the supplier, and they'll do that. Or you can be a little more hands-off and solve that problem later. So for example, this is a flash memory IC, and it has this part number. So if I were to upload the bill of materials file for this schematic, this part number would probably be enough for the manufacturer to resolve exactly the part they need to. Where you want to be explicit, you can actually provide the part number. So here I've opened up the symbol fields table, and I've provided a part number for just one part. It's a crystal. This crystal, I've found the crystal on LCSC, and I decided to hit this little add field button and put in LCSC part number, and I've populated that field. I've chosen exactly this because this is a special syntax that the PCB-A house will use to find that part. So I've been careful with how I've chosen this. The loop will close later, just bear with me. In any case, I've captured exactly the part number from the manufacturer that I want to use in the schematic. So that would be, a very constrained system. I've ID'd it exactly. Otherwise, we could generate a BOM using this BOM tool, and I'll link you to a plugin that will generate a BOM specifically for JLC, LCSC. So it has the exact format that they want. But you select the script you want to run, you generate the BOM, and it's full of all your components. And maybe you've specified parts, for others, maybe not. I've actually filmed this as I was designing the board because I wanted to show you this, but I didn't want to do it all at 1-to-1 speed. So here, once we upload the BOM data, which you're just uploading a CSV file, the manufacturer has done their best. They've looked at the designator, they've looked at the value, and they might have already selected a component. If they haven't, it's not a big deal. You just use the search utility and you find the component that you want. So in this case, we have a couple of parts down here, and this was before I actually filled in that part number. So I probably went off and went looking for that crystal and then backfilled the supplier's matched part number, which is this C number. But if I had brought my BOM file in with that already populated, it would have been there. So it's a very, very flexible process. This is really just to show you, or just to get you familiar with what the workflow looks like. So here I have no part selected, so I'm going to execute a search. I'm searching for an LED. I know I want an 0603 green LED. And then it's always good to select from the base component library if you can. And usually the parts that have the most abundant stock are going to be the cheapest. This kind of built-in search isn't as comprehensive as the parametric search, so you can kind of have your other window open where you're executing parametric search. You find the part you want and you just bring it in here. So you can see I get to select the parts as I go. So that's the BOM tool. And the other thing that we need is the footprint position file. So you'll go to File, Fabrication Outputs, Component Placement. Here we go. You generate your file and it'll generate a CSV, which looks something like this on the left. So on the left, we have the CSV that I've generated, and we have columns for reference, value, package, POSX, POSY, rotation, etc. On the right is the example file that the manufacturer provided for what they want. And so you've got a couple of options here. I think in the past, I literally just copy my values out of one sheet and into the other, and then just resubmit that file back to the manufacturer. They've just decided that the only information they care about is the designator, the XY coordinates, the layer, and the rotation in degrees. And so then at the upload step, when you're uploading your BOM file on the left and your position file on the right, you can click through. That takes you through to the component selection that we saw earlier. Here I'm looking for the USB connector that I wanted to use. And once we get past that step, this next bit's kind of amazing. You know, not all parts are oriented in their tape the same way. And so the manufacturer provides this utility to correct part rotation. Here I'm correcting the power regulator, and zooming around a bit, the interface is kind of weird, but here the flash chip needs rotating 90 degrees. And you can see that blue or purple dot that's indicating pin 1. So I just click the rotate on that, and it's literally this easy. And from memory, those are the only parts that I needed to correct. You might need to correct some offsets if you're doing like double-sided loads. They'll even do through-hole parts now, which is pretty amazing. They'll actually create a jig to send through, and I think they do like hand soldering or machine soldering for like really big runs. And just an indicative price, I got 2 boards assembled and another 3 unassembled boards for like $90. So I can't really remember how much the components made up of that total. You will pay more for this assembly service, but it's just another tool in your tool belt. Maybe that's worth it to you if you want to minimize that risk, or if you want to bake, if you have something that you know works and you just want to bake that solution, you can. You can buy the assembled board, and then forevermore in your account, you've got something that you can just click the reorder button on. And just like that, I think we're done. I think that draws a close to this KiCad Zero to Hero course. Thanks for joining me on this little journey. Thanks for listening to me wax philosophical about things that are probably totally unnecessary. But until next time, best of luck with your projects.